NASA is actively progressing with its Space Launch System, SLS program, aiming to complete the Core Stage 2 designated for the Artemis II lunar flyby mission by mid-December. This core stage is set to be transported to the Kennedy Space Center, KSC, for its launch. The Core Stage 2 faced delays earlier this year due to supply chain issues and complications at the Maikout Assembly Facility, MAF, with its prime contractor Boeing facing challenges related to a new weld tool issue that affected the liquid oxygen, LOX tank for the Core Stage 3 unit. Nevertheless, NASA remains committed to completing Core Stage 2 later this year and aims to finalize Core Stage 3 by late 2024 or early 2025. Core Stage 2's 4 RS-25 core stage engines were successfully installed in September, and the team is now focused on the testing and checkout processes to complete the final assembly. This stage is crucial for the Artemis II lunar flyby mission, which is set to be the first crewed lunar mission in over 50 years. The RS-25 engines were shipped to MAF from Aerojet Rocketdyne's facility at the nearby Stennis Space Center in September 2022, and they were originally planned to be installed early in 2023. However, various challenges, including a liquid oxygen feed line segment issue, contributed to the delays. The delay in Core Stage 3 production was mainly caused by welding problems in the LOX aft dome, which impacted the completion of the LOX tank. This tank's forward dome and 2 barrels were welded in 2022, but an issue with the aft LOX tank dome caused significant setbacks. Work on resolving this issue is in progress, and the team is working towards resuming welding on the LOX aft dome. Other elements of Core Stage 3, such as the LH2 tank and the inner tank, have already moved into the integration phase. The engine section, the most complex part of Core Stage 3, has made progress at the Kennedy Space Center, with orbital tube welding, wire harness installation, and other crucial tasks underway. Final assembly will be completed in the Vehicle Assembly Building, VAB, at KSC, with the upper 4 elements integrated at MAF. Despite the challenges, NASA is maintaining its goal of completing Core Stage 3 by the end of 2024, in line with the contractual date. The vertical final assembly approach at KSC offers more flexibility, allowing for continued access during integration, and it aligns well with the requirements for the Artemis III mission. Boeing and NASA are also working on the structures for the 4th core stage, Core Stage 4, at MAF, with the engine section structure expected to be shipped to KSC in the spring of 2024. This ongoing work demonstrates NASA's commitment to advancing its Artemis program, which aims to return humans to the moon and pave the way for future lunar exploration missions. The production of Core Stage 4 represents another step forward in NASA's ambitious plans for lunar exploration. As the agency moves forward, several key components and milestones are critical to ensuring the success of the Artemis program. For Core Stage 2, once the engines are fully integrated and the final assembly is complete, the focus will shift to the testing and checkout phase. This phase, known as Final Integrated Functional Testing, FIFT, is a crucial step to verify the core stage's performance and readiness for the upcoming mission. The successful completion of FIFT is a significant milestone in preparing the core stage for its journey to the Kennedy Space Center. The challenges faced in Core Stage 3 production, particularly with the LOX tank and welding issues, serve as a reminder of the complexities involved in building the SLS. These challenges have prompted a shift in the assembly process, with a vertical production cell at the Vehicle Assembly Building at KSC replacing the horizontal assembly approach used in earlier core stages. This transition allows for more efficient integration of the upper 4 elements and provides greater flexibility, ensuring that late-stage modifications or adjustments can be made without disrupting the overall assembly process. As Core Stage 3's components continue to take shape and undergo testing, the team at NASA and Boeing remain dedicated to the Artemis III mission, which is scheduled for late 2024 or early 2025. This mission represents a significant milestone in NASA's quest to return humans to the moon and lays the foundation for future lunar exploration endeavors. The Artemis program's long-term goal extends beyond the Artemis III mission. NASA envisions a sustainable lunar presence, enabling further scientific exploration, technology development, and international collaboration. The successful assembly and completion of each core stage are integral to achieving these objectives and ensuring that the Artemis program remains on course. Looking ahead, the progress on Core Stage 4 underscores NASA's commitment to advancing space exploration and pushing the boundaries of human knowledge. With each successful core stage assembly, the agency takes a significant step closer to realizing its vision of returning to the moon, conducting groundbreaking research, and preparing for even more ambitious missions in the future. The challenges encountered along the way only serve to underscore the complexity of the task at hand and the dedication of the individuals and teams working to overcome them. The Artemis program's ultimate goal is to create a sustainable presence on the moon that will serve as a launching point for further exploration into our solar system. This means not only returning astronauts to the lunar surface, but also establishing a habitat and infrastructure that will allow for extended stays, scientific research, and technological development. The challenges faced during the assembly of the SLS core stages, like those experienced with Core Stage 3, highlight the importance of rigorous testing and quality control in space exploration. NASA and its partners continue to refine their processes, adapt to unforeseen issues, and push the boundaries of human spaceflight. These challenges are inherent in the pursuit of groundbreaking missions and provide valuable lessons for future endeavors. As the Artemis program advances, international collaboration plays a significant role. NASA is working closely with partners such as the European Space Agency, ESA, the Japan Aerospace Exploration Agency, JAXA, and others to pool resources, knowledge, and expertise to achieve common goals. These collaborations enhance the capabilities and reach of the Artemis program, fostering a spirit of exploration that transcends borders. In addition to the Artemis missions, NASA is also developing the Gateway, a lunar outpost that will orbit the moon and serve as a staging point for crewed missions. This spacecraft will support Artemis missions and facilitate future missions to Mars and beyond. The Gateway will represent a new era of human space exploration and is expected to be a critical asset in our quest to explore the cosmos. The challenges and achievements in assembling SLS core stages, such as Core Stage 3 and the upcoming Core Stage 4, reflect the spirit of exploration and determination that drives the Artemis program. These endeavors demonstrate NASA's commitment to expanding our understanding of the universe, pushing the boundaries of human capability, and paving the way for future generations of explorers. In conclusion, the Artemis program represents a bold and visionary mission to return to the moon and eventually venture into deeper space. The successful assembly of SLS core stages is a testament to the dedication and expertise of the teams involved, and it sets the stage for extraordinary lunar and interplanetary exploration in the years to come. With each core stage's completion, we move one step closer to realizing the dream of humanity's sustained presence on the moon, and ultimately our journey to the stars.